Hello students, welcome to my channel Let's Mathemagic. So today in this video we will try to cover up the topic rational number, and in this video actually my main focus will be on to touch some important sums, and this video will give you a quick revision and depth idea about the chapter. I will be trying to discuss those sums which is especially coming in the board's paper. So I hope that this video will be help you a lot for your upcoming exam. And if you have any queries regarding this video, don't forget to comment down below, and I'll try to post individual videos for your queries. Enjoy the video and stay tuned on Mathemagic.
Just checking few sums from the book. So suppose the numbers are minus 2 by 5 and 1 by 7. Okay, so whenever the numbers are like this, so first of all what you need to do, you just need to make their denominators same. When you will see the denominators are already become same, then you need to see the how many rational numbers you need to put. So first of all let us make their denominators same. So which one was minus 2 by 5, another one was 1 by 7. So what you need to do, you need to do the LCM of both the denominators, like 5 and 7. Actually they are co-prime numbers, so no need to do their LCM. We can easily say that we need to multiply them, but I'm showing you. So 1 and 1, so it's coming 35. So let's make 35 now. So what will multiply now to make it 35? So 5 into 7 I need to multiply. So when you are multiplying 7 in down, you need to multiply the same term to the numerator as well. So we are getting actually minus 14 by 35. Acha, here we need to actually multiply 5 up and down to make 35 at the bottom. So we are getting here 5 by 35. Now see how many rational number they told us to put. They told us to put 10 rational number, and what student you will find out now, there will be 10 rational numbers inside them. Like how we will write the numbers like this manner. All the students please focus here now. See, it's minus 14 and here it is 5 plus 5 actually. So we will start just writing right after this, like after minus 14 if you go to the right side you will get minus 13, but 35 in the denominator will be fixed always. So next will be minus 12 by 35, then it will be minus 11 by 35, then it would be minus 10 by 35, then minus 9 by 35, then minus 8 by 35, minus 7 by 35. So you can say that we can write so many numbers like this, and after minus 7 then minus 6, then minus 5, then minus 4, then up to here, and sometimes some then 0 will come, then 1 by 35, and then 2 by, then up to 4 by 35. So you can see there are so many rational numbers are there. Now you have to write only 10 out of them. Like you can write the first 10, or what numbers I have written, out of them you just take any 10 of them, and here all the numbers will be divided by 35. Okay students, I hope you have understood, and this kinds of sum there is given in the exercise 1.1. okay, so I have shown one. I hope that you can do the rest of the sums. You have already done it, but still as I've told, this is a quick revision of the chapters. So if you follow the video, there will be a quick revision on this chapter 1. Acha, let's proceed to the next type of question. Okay, so in the next type you will find out that they will tell you, they will show some numbers which are irrational number. Like if I say let us take this sum, another question. So suppose it's given root 7, and we need to show that root 7 is actually a irrational number. So this sums, for some students this sums looks a little bit tricky, so let me show you here now. Acha, so first of all what we will assume that this is actually a rational, not an irrational number. Means that we will say that it can be expressed by p by q. You all know that a rational number can be expressed by p by q. Rational number can be expressed by p by q. But if one number is a irrational number, that cannot be expressed by p by q. Make sure that this q is a non-zero number. This q is a non-zero number, and p and q both should be co-prime numbers. This means that they will not share any common factors. Okay, p and q will be co-prime. P and q will be co-prime. Okay, co-prime. Acha, now as they have told us to make that to prove that actually root 7 is a irrational number, but what we will take that let us take that root 7 is a rational number. So as root 7 as per our assumption it's a rational number, so a rational number can be expressed by p by q. So we have expressed root over 7 as p by q. Now what we'll do, we'll do the square in the both side. So root 7 will become 7, this will be p square, this will be q square, and the next line we can get 7 7q square equals to p square. This is a very important line for this sum. So here we can see that 7q square is always divisible by 7, sure, because any number, like suppose if I say 2 into 10, means no need to see this 10, as 2 is there in front of that 10, so it can be divisible by 2 because this 2 will be cancelled out. Like 2 into 7 also will be divisible by 2 because 2 will be cancelled out and there will be a 7 as a quotient. So what we have understood that if any number is there as multiplied to any term like 7 into q square, so 7q square, this term will be always divisible by 7 whatever the value that q is having. Okay, whatever value the q is having, this 7q square will be always divisible by 7. We no need to see what is the value of q and what is the value of q square. Okay, acha. So now we will say that as 7q square is actually equal with p square, so if 7p square q square is divisible by 7, so then p square also should be divisible by 7, right? So p square is divisible by 7. So when p square is divisible by 7, we can write that by that theorem, there was two theorem 1, by this theorem 1 we can say that in theorem 1 actually it was told that if there is a number a, okay, then if there is a prime number p, prime number p is a prime number, okay, so then if p divides a square, if p divides a square, then it would imply that the p will divides a also. So now here if 7 divides p square, means see, p square divisible by 7 means what? 7 divides p square. So here 7 is a prime number, so as like p. So now if 7 divides p square, then 7 divides p also. So if 7 divides p means what? P is divisible by 7. So therefore p can be expressed as 7 into m, where this m belongs to any number. Any number means any integer. Okay, any integer. Acha. Now what we can say that this value of p, that is 7m, this value of p, that is 7m, now can be inserted here in this equation. All of you please look at here. This value of p I will insert here. Okay, this value of p I will insert here. Now see what I will get now. Then if I put it here, then I will get this kind of thing. 7q square equals to p square is now will become 49m square. Now 49 and 7 will cancel, so it would become 7. So q square is coming 7m square, right students? So now as 7m square is always divisible by 7, just like as I have told you that 7q square is divisible by 7. So for that by that same thing, by that same reason, 7m square will be always divisible by 7. So then as q square and 7m square they are equal, so then q square is also divisible by 7. Means what? 7 divides q square. Okay, 7 divides q square. Now by that theorem 1, that same theorem 1, here we can say that 7 divides q as well, right? 7 divides q. So now students, all of you check here. 7 divides q means q is divisible by 7, and here somewhere it's written that 7 divides p as well. That means p is also divisible by 7. So p and q actually they are both divisible by 7. That means what? They are having a common factor. So as they are having a common factor, so this assumption was wrong, because I have told you before earlier that p and q should be co-prime, so they should not share any common factor. But here in this sum, means at the end of the sum, what we have got that they both are divisible by 7. So both are having 7 as their factor. So here this p and q are not following the law that's held by the rational number. So then our assumption was wrong, that we have assumed that root 7 is actually a rational number, and that's why root 7 can be expressed as p by q. So our assumption was wrong. So root 7 is not a rational, it's a irrational number. I hope all of you have understood. Acha. So this is one type. that to show that like one number they will give and you need to show that that is a irrational number. Like the same method you will prove it. Okay, I have already shown this sum and the full sum is on board. You can pause the video and you can check it out if anywhere there is any kinds of doubt. Okay, acha. So now I'll move on to the next type. Acha, in the next type they will again in the sum they will again say you that to show one number as a irrational number, but that is not a single number. They will give you a number like this. Maybe the sum is like 3 minus root 2. So they will say that prove that PT that this 3 by 2 itself is a irrational number. Okay, this is a irrational number. Now again we will do like the same manner. We will say that let 3 minus root 2 is it is actually rational. We'll say that it's a rational number. Now as it's a rational number, we will take it like something like x. We will take it x. Now we'll square both the sides. So 3 minus root 2 its square is equals to x square. Okay, now we'll do the square. So a square means 9 minus 2 into a into b plus b square. Root 2 square will become, sorry, it's plus root 2 square will become only 2, so it's x square. So students, you can see this 9 and this plus 2 will become it will give you a 11, and this whole thing will give you a minus 6 root 2, right? So it's x square, right, like this. Achha. So now in the next line what we can see that I will take this x square this side, so it would be 11 minus x square, and this 6 root 2 to that side. So then if we divide this 6 here, so I'll get like this 11 minus x square by 6 is equals to root 2. Now here is a very important thing that we have already received. Now all the students please focus on this part. See, I have told that root 3 minus 3 minus root 2 it's a rational number. Here it is written. So I have assumed like that, and as 3 minus root 2 is equal with x, that means x is also a rational number, right? So now if x is a rational number, then square of x will give you another one rational number. Now we all know that 11 is a rational number, so subtraction of two rational number will give you another one rational number. So what we have got that this one, this numerator is a rational number, and here this 6 is also a rational number only, it's not a irrational. So all the numbers are rational, so this whole term, that is 11 minus x square by 6, it's a rational number. It is denoted by capital Q, like natural number denoted by capital N, so rational number is denoted by capital Q. So then this is a rational number. Now we know that root 2 is a irrational number, right? So how they can be equal then? So we have again came to something that is something wrong, or something contradiction happened already. So then again we will say that our assumption that we have taken that root 3 minus root 2 is a rational number, that was maybe wrong. So actually it's a irrational number. So like that manner we will now show that this 3 minus root 2 is a irrational number. I hope all of you have understood. If there is any problem, go backward and watch it once again. Achha, moving towards the next type. We will rationalize the irrational portion if it is on the denominator. Like suppose if you have a number like this 10 by root 7. Now what we know that root 7 is a surds. So surds means what? If there is any root part, then we need to eliminate that. But make sure that if the root part is on the numerator, then we don't have any problem. We rationalize only when the root part is on the denominator part. So what we will do in this particular case? This is very simple. Here what you need to do, you need to just product root over 7 and root over 7 in numerator and denominator both. See what happens. See, here we have got 10 root 7 by only 7. Now see our problem solved. What I have told, if root part is there in the numerator, we don't have any problem. But now see, the denominator is totally free of root. So our problem is solved out. But this is a actually very simple type. But what type of sum actually comes in the board papers? So you will find out this kind of data. Like suppose if I say any sum I am taking just from the book arbitrarily. Like suppose it is the sum I have just got from a part 2 plus root 3 by 3 root 2 minus 2 root 3. So this is the sum. Suppose this is the sum. So in this sum, what you will do? First of all, you need to see the denominator. You will find out some root portions are there. Then what you will do? Then you just need to check that what is the sign in between. You need to change the sign. So in mind, you need to change the sign. So if I change the sign, what it would be? It would be 3 root 2 plus 2 root 3, right students? So that number, what you have thought in your mind, you have to multiply again like the same manner, like up and down means in the numerator and denominator. So let's multiply 3 root 2 plus 2 root 3 and in down also 3 root 2 plus 2 root 3. So then you will find out one thing. See, in denominator we have got a formula. A minus b into a plus b. So all of us know that a plus b into a minus b gives us a formula of a square minus b square. So same thing here. What is our a? 3 root 2. So then 3 root 2 its square minus b square. B is 2 root 3 its square. And in numerator you will find out there is a product. So root 2 into 3 root 2 it would become 6. Acha. Root 2 into 2 root 3 it would become 2 root 6. Acha. Root 3 into 3 root 2 will become plus 3 root 6. Acha. Root 3 into 2 root 3 will become only 6. Yeah. Acha. So let's see what will come. Acha, here we can get something like this. This 6 and this 6 will become 12 and 2 root 6 and 3 root 6 will make a 5 root 6. Acha, here we are getting 3 root 2 square. It would be 9 and 2. It's 18. Acha, 2 root 3 will be 12. Acha, here it's coming 6. So 12 plus 5 root 6 by 6. So you see the number it's now rationalized. And this number what was given in the question like this part. This number and this number means what we have got at the last, this number is same actually because we have multiplied the same thing up and down. So then the fraction won't be changed. Like suppose students, if I say you 5 by 6, if I multiply 3 up and down, so it would look like 15 by 18. But if you again cancel by 3, again you will get back the same fraction again. So then 15 by 18 is actually same like 5 by 6 but looks different, right? So anyway, so then it's rationalized now. See, there is no root part in the denominator. So I hope all of you have understood. So if there is still any problem, you can drop a mail in my mail ID. So all of you know my mail ID. So once again, all the best for the upcoming examination. I'll try to post another video regarding the other chapters that you are having in your unit 2. Thanks for watching this video. See you in the next video very soon. Till then, stay safe, stay healthy. Bye bye. Keep in touch.